Welcome to Mrs. Z's Chemistry. In this video, we will finish 4.3 and learn about stoichiometry with grams. First, let's review stoichiometry with moles. In this chemical reaction, we have a balanced aluminum and oxygen, forming aluminum oxide. This means that you need 4 moles of aluminum for every 3 moles of oxygen in order to produce 2 moles of aluminum oxide. The ratio is 4 to 3 to 2. Stoichiometry means we are going to use these balanced chemical reaction coefficients as mole ratios to relate the compounds to each other. So let's do a quick review of mole stoichiometry. When 9.82 moles of aluminum reacts with oxygen, how many moles of aluminum oxide are produced? So we're going to start with what we're given, 9.82 moles of aluminum. In the problem, it's saying that aluminum reacts with oxygen. That's just describing the chemical reaction that aluminum is in fact reacting with oxygen. But it's asking for how many moles of aluminum oxide are produced. So we don't need to do anything with the oxygen in the math of this problem. We're going to write moles of aluminum on bottom so that moles of aluminum get to cancel. The problem is asking for aluminum oxide, so that is this compound. The numbers that go in here are from the coefficients. We put a 4 here and a 2 here. 4.82 moles divided by 2, which your calculator can either show times 2 divided by 4, or of course your calculator, you can just do divide by 2 if you want to. So then the answer is 4.91 moles of aluminum oxide. All right, let's do the next one. If 3.17 moles of aluminum oxide were produced, how many moles of oxygen was needed? So we've got 3.17 moles of Al2O3. We're going to put moles of Al2O3 on bottom so that that gets to cancel, and the problem is asking for moles of oxygen. Remember that in nature, oxygen always exists as O2. It's 2 oxygen molecules or atoms bonded together as an oxygen molecule. Now we need to use our coefficients of oxygen to aluminum oxide. When we multiply by 3 and divide by 2, we get 4.755 moles of O2. All right, now let's introduce grams. First, let's do one more mole-to-mole stoichiometry. How many moles of oxygen are needed to completely react 1 mole of aluminum? So we're asked for this one. How many moles of oxygen? And we're given this one, 1 mole of aluminum. So we're going to start with what we're given, 1 mole of Al. We're going to put the moles of Al on bottom and the moles of O2 on top, since that's what we are asked for. Then we're going to add in the coefficients here. We have a 4 to 3 ratio. You can see now that the answer is 3/4 of a mole, or 0.75 moles of O2. When you have 1 mole of aluminum and it reacts in a 4 to 3 ratio, you only need 3/4 of a mole of oxygen. Now let's do this exact same problem. How many moles of oxygen are needed to completely react 1 gram of aluminum? So again, we're going to start with what we're given, 1 gram of aluminum. At some point, we're going to want to use the chemical reaction. Oops, don't need an arrow here. We're going to need to use the mole ratio that was used in the previous. We're going to need to use that mole ratio, but we can't put that one in first because moles of aluminum, we don't want to put moles of aluminum down here. Moles of aluminum don't cancel with grams of aluminum. So we need to use the molar mass of aluminum. That is 26.98. That is just written straight on the periodic table for aluminum. And this is always per 1 mole. Molar mass is something we learned back in chapter 3, and it's always per 1 mole. I know that in this chemical reaction we have a 4, but that has to do with the chemical reaction. Aluminum on its own, independent of any chemical reaction, weighs almost 27 grams, 26.98 grams for every 1 mole of aluminum. Now we get to use the mole ratio. So we put our 4 moles of aluminum on bottom, our moles of oxygen on top here. Let's add in the 4 to 3. And now we get to divide. You're going to take 1 gram, divide by 26.98, and then times 3 and divide by 4. And we have 0.0278 moles of oxygen. So you can see we ended up using this mole ratio right here. We just needed to convert to moles first. So I like to say that in stoichiometry, moles is the goals. We cannot use the mole ratio or those coefficient ratios in a gram ratio. It is always a mole ratio. This is problem 8 on the problem set. Go ahead and try to work these out before I show you the answer. Here are the answers to both of them. We start with what we're given. 20 grams of nitrogen reacts. How many moles of N2O are formed? So we cannot use our 2 to 2 mole ratio until we convert to moles. The molar mass of nitrogen right here, make sure you add 2 nitrogen atoms because of this little subscript 2 here. So we have 28.01 grams per 1 mole of nitrogen. Now we have moles of nitrogen on top, and we can now use the mole ratio of 2 to 2. These 2's come from the coefficient of in the balanced chemical reaction. Now, as far as your calculator is concerned, it doesn't need to know about the times 2 divided by 2. Of course, that doesn't change the math or the answer at all. But for showing your work, you have to put this in because this is how we are converting from nitrogen to N2O. For the second problem, we have 13.9 grams of N2O. We need to convert to moles because we cannot use the mole ratio until we have moles of N2O. 44.01, that is just 2 nitrogens and 1 oxygen added up. Now we get to cancel our moles of N2O by using the mole ratio. This 2 and this 1 come from right here. This 2 and then the 1, implied 1 coefficient for O2. Pause to see if you can work these out before looking ahead at the answers. Here are the answers. In the first problem, we were given an amount of moles, 29.5 moles of sulfur. Now, because moles is the goals, we're already in moles. Don't convert to grams. Don't use molar mass of sulfur. We don't want that. So use moles of sulfur, the 2 coefficient, to get to moles of SO3, the sulfur trioxide, happens to be a 2 as well. So we do have a 2 to 2 ratio here, which means your calculator doesn't need to know about this. But for showing your work, this is key. This is what stoichiometry is right here. This mole ratio, you must show it in your work. Now you get to cancel your moles of sulfur because we don't want anything to do with sulfur anymore. The problem is asking for how many grams of sulfur trioxide. 1 mole of sulfur trioxide is equal to 80.066 grams of sulfur trioxide. That's just 1 sulfur and 3 oxygens added up. Now we get to cancel our moles of sulfur trioxide, and we're left with grams of sulfur trioxide. Multiply and divide, and we have this answer. Pause to see if you can work these problems. In these problems, we were given an amount of grams and asked for an amount of grams. So we need to use 2 molar masses and the mole ratio. So first, start with what you're given. 1 gram of table salt. In case you didn't know, this is table salt, sodium chloride, NaCl. So we start with what we're given, 1 gram of NaCl. We cannot use the mole ratio of 2 to 2 here until we convert to moles. So 58.44 is the molar mass of sodium chloride. 1 sodium plus 1 chlorine added up. So now we get to cancel our grams of sodium chloride, and now we have moles of sodium chloride. Moles are the goals. Now we get to use the mole ratio of 2 to 2. So we get to cancel moles of sodium chloride, and now we have moles of sodium, Na. Again, as far as your calculator is concerned, this 2 to 2 ratio doesn't make any sense. It doesn't change the math. However, for showing your work, this is how we converted from sodium chloride to sodium. Those are 2 very different substances. Then the problem is asking for how many grams of sodium. So now we need to use the molar mass of sodium. So we get to cancel our moles of sodium, and 22.99 grams of sodium is what we get from the periodic table for the molar mass of sodium. The second problem starts with grams of chlorine, 13 grams, and we're asked for how many grams of table salt, which again is the sodium chloride. Remember that chlorine is diatomic, and so you need to add up the mass of 2 chlorines to get the 70.9. This cancels our grams of chlorine. Now we have moles of chlorine. Use the mole ratio of 1 to 2, and that cancels our moles of chlorine. Then we use the molar mass of sodium chloride to cancel the moles of sodium chloride and get grams of sodium chloride.